Let's now look at how we will solve question 1 of the first MCQ from mid-year 2011. Okay, what is the reading shown by the keyword is vernier calipers? You can recall vernier calipers can read up to 2 decimal places. What I mean is that it can read, for example, measurements of 5.22 centimeter. Okay, this is what it means by 2 decimal places. Okay, so this is the number of decimal places that the instrument vernier calipers can measure. So in this case, we will look at the how do we read this measurement. Okay, first you notice the first and the last digit here is 10 to 11. So in between this is just like your ruler. So in this case, this is 10. So the next one will be 10, 10.1, and followed by the next marking here, which is 10.2. Okay, the next reading here will be, in this case, will be 10.3. Okay, so this is how we read this part of the scale. In this case, this on top is called your main scale. Okay, and the one below is called your vernier scale. Okay, so in order to get the reading, we must first focus on the zero marking here. Okay, so usually we'll read on the left of the zero marking. So on the left of the zero marking, in this case, this will read as 10.2. So 10.2 is my first set of reading. And remember what I said at the beginning, vernier calipers can read up to 2 decimal places. If I read only 10.2, I'm still short of one more decimal place. So how do I get the second decimal place? In this case, we focus on the numberings below. You notice 0 to 5 and 10. Here should be 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, one marking is actually one division. So how do we read the second decimal place again? Okay, we'll focus on the top and the bottom line that forms a straight line. So in this case, I need to focus on this portion. So how do I read this portion? You notice just now I counted, so this is 7. So my final answer will be 10.2, just now what I've gotten here, plus my second decimal place, which is 7. So this is my answer for question 1, which is option A. Okay, so let's now move on to the question 2. Okay, in this case, question 2 is asking about micrometer screw gauge. Okay, you compare micrometer screw gauge and vernier calipers. The difference is micrometer can read the unit in mm. So mm is a smaller scale. Okay, so how do we start reading? Okay, first try to understand what these two lines mean. Okay, 5 before 5 is actually 4. Okay, this is very important. So one division is actually 1 mm. And below 4, there's something below. So this is 4. This one represents a 0.5. So 4.5. And here is actually 5.5. Okay, this is very important. So how do we read? We read first 5.5. So we write down 5.5 first. Because the 5.5 is the number that is nearest to this thing called your sleeve. Okay, so remember all these instruments can read up to 2 decimal places. So in this case, my 5.5 is not enough. I'm still short of one more decimal place. How do I get the second decimal place? So in this case, the next step becomes very important, which is to form another straight line. Remember just now we have to form a straight line. So instead of just now a vertical line here, now we form a horizontal line. So if we form a horizontal line, we read this as 30, but you don't record as 30, you must record this as 0.30. Okay, so now we must add 0.30 here. Okay, a lot of students get very confused here, so you must take note of this. You see 30 is actually 0.30. So in this case, I add together, so my answer will be 5.80. Remember this is mm, so millimeter. So my answer will be D. Okay, so this is for question 2. Let me move on to the next question, which is question 3. How do we solve question 3? Okay, question 3, the difference is, if you compare these two diagrams, this one is a cube. Okay, what do you mean by cube? Cube means that the length and the breadth, length will be equal to the breadth will be equal to your height. Okay, so if this is x, the height is x, the length will also be x, and the breadth will also be x. Okay, this is very important. So in this case, if the height is 2x, the length will be 2x, and the breadth will be 2x. Why is this important? Because later on we're going to find something called volume. So you want to find volume of this cube. I take x times x times x times x 3 times, so it's x cubed. In this case, my volume here is actually 2x times 2x, and I will cube it. So in this case, when I cube it, I get 8x cubed. Okay, can you see the difference? So right now, the question is the weight of small cube, which is referring to this, is W. What is the weight of the larger cube? Now it's asking about weight. So once you see the word weight, try to recall the relationship between weight and volume or mass. So in this case, the first equation I can recall is weight is actually equal to my mass of my cube times the g. Okay, so the mass will affect the weight. Okay, so this is my first formula. But this is not enough because I'm only given the change in volume. So I need to recall another formula that can relate volume mass. So the next formula I can recall relating to volume and mass is actually density. Because if I can remember, density is actually equal to mass over volume. So in this case, my mass is actually equal to my density of my material times its volume. Okay, so this relationship become very important because volume is now directly related to my mass. So the bigger it is, the space it occupies, the bigger will be its mass, providing that it's the same material. So this word called, in this case, the word same material become very important. So in this case, when my volume increase, my mass will increase, and if you take note of the first relationship, if your mass increase, my weight will also increase. So in this case, you notice just now we calculated volume. So actually my volume has increased by 8 times. So here is really times 8. Here will be times 8. Here will be also, the weight will also times 8. So the best answer for this question is actually C. Okay, so this is for question 3. Okay, let me move on to the last question of page 2. In this case, it's on the topic of speed and acceleration. You can see the option speed and acceleration. So it says that a mass of 10 kg falls from rest. Fall from rest means the speed is 0. But in this case, this is actually not a very crucial information. Which of the following statement is correct? Okay, any object that falls, actually falls is the keyword. Any object that falls has this special property called acceleration that is due to free fall. Okay, acceleration due to free fall. You can recall this. There's a special number a, which is equal to 10 meter per s squared, and this number will hold true on Earth. Okay, so this number is actually a constant number. It doesn't change. Constant number. Okay, so if we look at all these options, the best answer that we can choose is actually option D. Why? Because it says that the object falls with a constant acceleration of 10 meters per second squared. Okay, so this question is actually a concept question about whether are you able to recall this special relationship that any object that falls, there's this acceleration, constant acceleration due to free fall, which is 10 meters per second squared. So we'll stop at page 2 first. Okay, so we'll stop the video first.